So yeah, we've got a really diverse panel in that we've got someone representing the adoption around this trend from large companies in Hugo. We've got someone working at the sort of cutting edge of what Google is doing here, and then we've obviously got distinguished professor of Marconi in computer systems from Cambridge. So a pretty great group. The first thing I'd love to get your thoughts on are the underlying trends motivating a shift to the edge. So I've heard that latency issues are a driver with, for example, inference at the edge in kind of high performance situations. I've heard about the need to do more federated learning. There's privacy issues come up quite a bit. What do you guys see when you're sort of looking at actual adoption of this technology? Where the developer enthusiasm is, where the large company enthusiasm is. What are the real drivers here?
Should I go first?
Yeah.
Okay. So I'll jump right in there. I think there are almost like multiple stages of interest for companies. I think initially large organizations are going to be interested in focusing on use cases that give them a short-term benefit. So I think they'll go very much into operational use cases. I think the smart metering one is a basic one, right? Because currently they're building this whole infrastructure, which is actually not required to do things efficiently. So I think once companies trust the capabilities that exist already, but trust to implement them at scale at the heart of their operations, they're very quickly going to find themselves in the position of almost a disruptor of all of the other services they're consuming today to feed a machine that is just not efficient and not operating as it should.
Very interesting. And Pete, when you think about all the people building on TensorFlow, what do you think are the trends that will motivate adoption?
So the best concrete example that I saw very early on when I joined Google was there was a startup called WordLens that was acquired by Google that was doing translation of foreign language menus and signs in real time on the phone. And it was integrated into Google Translate. And it was a little surprising to some of the old-time Google Translate people because they were like, oh, well, we had the ability to take a photo and send it up to the server and get the results back. And when we run the WordLens models through our assessments, like the WordLens models aren't as accurate as the ones that we had on the server because they were running, on phones like 4 years ago. But what we found was the user satisfaction was much higher because when people were using the real-time view in the camera that was running on the phone with this almost instant interaction, they were actually able to sort of like wiggle the phone and see the translation changing and like snap into place as they were using it. So that really has been a very strong, consistent theme throughout all of the products inside and outside Google that we've worked with, has been the interactivity. Like the user interactivity really is like the killer application. And that sometimes surprises people when they think about Google. They think about Google maybe as a cloud company. But actually, if you think about some of the most successful products that Google has had, like Gmail and Google Maps, that's all been about giving client interactivity where it makes sense. So really, the interactivity for adoption has been key.
So in some ways, you're both describing latency as the sort of the core driver there in both cases in terms of the commercial and the sort of developer excitement. Is that do you see the same latency as the core driver here?
I think it's a good argument. Availability is another dimension that is related. The other thing is just feasibility. A lot of early machine learning was done in a kind of lazy way where people that knew a lot of stats and a little bit of programming would use some of the platforms like Spark R or whatever and throw something up on the cloud. And you have these huge memory footprints. But now, in the last 3 or 4 years, we've had people pushing these systems that are trained on mobile devices. And they do things like compress the neural net and leave out layers probabilistically. There's a whole bunch of techniques which, and the maturity and the sort of cross-discipline of people that can program and get some stats and have a feel for the application requirement. It could be in the corporate world, it can be in the research academic world. We're seeing that coming together. And so the fact is you really can do some pretty impressive things. And you may take a hit on accuracy, and trade that off against latency, or you may actually just get the same accuracy. In some cases, firing something up on Hadoop or whatever in the cloud, you actually lost performance when you did that, in a big way.
Yeah.
And there's a great blog by Frank McCherry who did this with graph processing, which is one of the most intensive things in social media analytics. And he showed that dozens of papers out there had actually got worse performance than if they'd run the algorithm standalone on their laptop. Then, they'd all kind of optimized something running the cloud for 100 cores or whatever, and did slightly better than someone else's, but nobody bothered trying with one core. So there's a big lesson in that.
Very interesting. So I guess latency followed by performance, perhaps, as a sort of an early sense of where this is going. Hugo, when you work with companies primarily in the energy and oil and gas spaces, what are some examples of kind of, outside of, for example, the consumer applications of menu translation, what are some sort of business applications that you're seeing where latency is particularly important?
So, these companies own large infrastructures, right? Physical assets that require maintenance and care from a lot of different engineers, a lot of different data sources, a lot of different sensors, all being aggregated, brought together up into the cloud to then be processed, to then inform someone to make a decision. And I think this is the key thing that links very well with the impact, right? The impact is not delivering the insight. The impact is putting the insight on the hand of the engineer that is in front of that asset in that specific moment, right? So I think that's a very easy use case to actually think about. Is there a way to, instead of orchestrate, and we had a chat about this earlier, am I going to build an infrastructure like those 3 layers that one of the keynotes was just up showing? Am I going to build all of that infrastructure? Or am I going to just adopt someone that had an idea to solve that very narrow use case, fixing some sort of generator, right? An engineer is on the spot. Is there an opportunity to actually, for that specific array of use cases around that asset, for someone to have a device that can read the sensors, can process and do the computation and give you the instruction to solve it on the spot?
Yeah.
Or is it going to aggregate, try to send it off into the cloud, to try to build a number of decision-making criteria, to send it to someone, for someone to make a decision to then tell that engineer what to do?
Yeah.
Right? When you put it like this, logically, it doesn't make any sense.
Yeah.
And I see a big opportunity here, and also a big, almost like side disruption, a lateral disruption trend here, which is when someone brings the hardware together with the software together with the use case for a very narrow use case, that narrow use case must happen 1 million times across the world in that industry. That's a big market opportunity, right? We're talking about assets that cost millions to run. So the potential benefit of even narrow use case is going to be very concrete when someone takes the first step of not just replicating what they have today on that type of infrastructure, because I think that's the problem.
So if we are going to see those sort of niche use cases bloom around this, do you guys feel there will be one of those sort of, endlessly analogized Cambrian explosions here, where you see a ton of different custom hardware and software emerge? Or do you think this will fit into the broad trend around centralization of sort of machine learning software and hardware?
I'm not the expert on hardware. Certainly, when you use cloud-based machine learning, we're starting to use more and more exotic accelerators, TPU from Google, GPUs from NVIDIA, whatever, or FPGAs. There's a whole bunch of them. Microsoft pushed stuff out onto the RDMA NIC stuff they have in their data center.
Yeah.
But the fact is, you have some of these exotic accelerators, not that exotic, they exist on low-end devices, and you're going to see a very large number. I mean, if you look in, I don't know if it's still called Google X, but the people developing the processors to run the AI in the car, which absolutely is not going to depend on the cloud. It's going to be local, trust me.
Yeah.
They are really, really smart software hardware engineers, and I mean, you probably know a zillion times more about it. But there are a bunch of other examples of things like that have happened, and I think, I don't think there'll be an explosion of many kinds of hardware. It might be a small number, in the same way we have a small number of types of conventional processors.
Yeah.
You have basically ARM and Intel,
Yeah.
a couple of other things out there. And that's largely because there aren't that many engineers who can do the software hardware interface side of things. But once that settles down a bit, that will lead to this definite kind of explosion of these specialized apps. And we have this great software infrastructure that allow us to do this super specialization.
Can I just dig in a bit more there, though? Because it does seem to me that the centralized model sort of has pretty substantial barriers to entry. You know, if you want to start fabricating custom silicon like an IPU or a GPU or a TPU, that requires a lot of capital. It would seem that with a move to the edge where you're just doing less, but you're doing more locally, it would mean that smaller players can more easily enter the market. What do you think, Pete? Can anyone come at Google on this?
So I'm just a humble engineer. So from a technical side, what I find really interesting is that things that are like DSPs and microcontrollers actually already have pretty good support for doing 8-bit multiply adds, which is essentially all you need to run a lot of neural networks. Like that's where all the heavy compute is going. So what I'm kind of fascinated by is, like you were saying about the Raspberry Pi, like years ago I actually open sourced some code to run matrix multiplies on the Raspberry Pi GPU because they actually opened up the assembler to let you play with it, and that actually sort of helped drive a lot of the work I've been doing sort of since I got to Google, is that there's this massive Lego box full of existing components, even disregarding stuff that may be coming, that you can plug together that's already optimized for very, very low power. And it's just the process of actually trying to connect the right people and get the microcontroller engineers talking to the machine learning kind of systems engineers. And if, for example, ARM with their CMSys library, which is aimed at microcontrollers, now has a whole bunch of support for important routines for doing neural networks. So that means that all the ARM Cortex-M series chips are actually in a great position to be kind of existing platforms for a lot of the stuff that's out there.
Yeah. How do you guys see this all fitting together with the sort of investments that have been made historically in sort of centralized systems? I think, John, maybe you had some thoughts on that?
Well, the minimum is that we still require root of trust for ID, sign-on, and we also have, I think you can split the world into organizations that have very persistent curated data over a population. Depends what country you're from, but we're luckily in a country where the NHS is a state-run system, and most of Europe has something similar, where people pretty much will trust those people to keep the patient record data in a sensible way, and then running model inferencing over that in the data centers in an enclave inside the healthcare system seems like an incredibly useful thing, and you might build really cool predictors or even causal inferencing about what treatment is better or what is causing this particular epidemic of whatever, asthma or obesity or whatever. So I think that will remain as a system that's there for big infrastructural organizations. But I think from the sort of business perspective, I'm not the guy to ask, what happens in the edge. But I think you could imagine a world where we really don't trust not only the liability and not only the latency and privacy and energy costs, but moving data to the center. We have too many examples of your personal data being exploited in the wrong way. And so you can imagine when that happens, the liability, I won't mention GDPR, like I won't mention blockchain, but it's sufficiently high that people might say it's a better business case to do the smart thing of leaving the stuff in a smart home and then only getting aggregate statistics, which is still good enough for many of the applications, moving to some central system for the electricity generating company or whatever it happens to be. So I think there is a hybrid world you can see in the future, but those big cloud systems, they're not so big. I mean, how many data centers in the UK have 35 million cores? If I take 35 million households in the UK, which is a number of people with, TVs with digital television, which has probably got a processor in, which is probably more powerful than the stuff you need, that's 35 million. I could run some pretty hefty distributed machine learning over, people's well-being and their fitness and their food habits and so on, without the invasion of privacy, without the latency problem availability. And I could probably beat some of those data centers, hands down, I suspect. Yeah.
And so, that kind of gets, I guess, us a little bit into this question of sort of privacy as a motivating force for all this stuff. So it wasn't in our top 2 or top 3 drivers of the adoption here, but there's obviously lots of interesting work going on around sort of differential privacy, homomorphic encryption, zero-knowledge proofs, all these sorts of techniques that help to sort of do something at the edge that's private and then doing something in the center that's sort of public. How do you guys see that being used at the moment?
I think there's a clear balance to be achieved. I think many of these techniques, like any privacy technique, I think it's trying to serve as a proxy for an actual value proposition that's missing, right? I think that the brands are still too stuck on the ways that they've done things. And brands, I mean large organizations. And they need to take one step forward and actually redesign the principle of what they're trying to do for their customers and their users instead of just applying the new technology to improve what they have. I think that's going to be a massive shift around what's the purpose of the company. And once companies realize this, companies will have a brand new value proposition to actually incentivize those edge use cases. And again, I think once someone realizes that they don't have to build all of the infrastructure, all of the process change of everything that sits below the sea level on the iceberg, and they can just redesign what they do with their clients on the edge, I bet there's going to be another cycle of brand new startups that come in and disrupt whole industries with concepts like that. Right? So imagine a startup that could actually build one of those devices that is used by any engineer that's doing maintenance on any electrical device, and you open that up through the internet to the whole world. How big would that market be? And how many different industries would it potentially disrupt, right?
And I don't see much of a barrier for deployment. There's a timescale thing because you have these logistic curves for any large-scale deployment, but I worked on the internet since the 70s, which is kind of a scary thought. And I remember when friends of mine started getting sent a DSL Wi-Fi router to install themselves. And in fact, we've been doing that earlier. There were a whole Cisco, people remember that company, sponsored a whole bunch of school kids to go out and roll out internet access across towns in America, and then there were similar things in Europe. So these things can be done. And the internet was done in a decentralized way. It was only a kind of weird accident of business model that Google discovered click-through and advertising associated with PageRank that they went, oh, well, let's do the two-sided market thing, and everyone copied it for a while. 100 years from now, people look back on this as a sort of weird bit of the Dark Ages, I think, and say, that was a very strange experiment you did there, a bit like free market economics, probably or Marxism is probably a terrible error. What were you thinking?
That's interesting. I mean, I had the privilege of spending the weekend at a conference with Vint Cerf, and he had a very pithy description of his thoughts when commercializing the internet, which was that he had no idea what the applications were going to be. So he thought, well, everything should talk to everything, right? And in some ways, there is a sort of a broader trend here to everything being able to talk to everything, right? It empowers a lot of these agents at the edge to do more themselves, share, and sort of participate more economically in the system. Does that feel right as a characterization?
Yeah, that's exactly. And the model of the value proposition of the internet it's sometimes called Metcalfes Law. It refers to n squared. There are people like Dave Reed at MIT who go, no, it's n log n, but it's still super linear. Yeah. In other words, you add more people to your n, the increase in value goes up. When you centralize things in the cloud, you essentially silo every service in that cloud service, so you have sublinear because you have a cost associated with it. So people forgot the whole point of the internet. So you add somebody, they might add value by combining things in a different way, not just themselves, but with arbitrary other people. And so this was sort of missing. And I think maybe that's what you're going to get this explosion, because that value is when you go superlinear, you go back to, I know I don't want to go back into the dot-com fiasco and AI winter, but actually machine learning is not AI, it's fine, it's good, it does work, it is useful, and that value proposition is great. Venture capitalists get it totally, and you talk to them, you go, our value may be 30 million quid today, but we're scaling users, I can't mention the hat company, but we're scaling users at superlinear, and the value should scale that way, maybe. If this works, if I'm wrong, then well, too bad.
Yeah. Okay, so we've done probably most of our time on the breathy excitement of edgification of intelligence. Maybe we should spend a little bit of time talking about the challenges. So security, sort of updates, patches, those kind of questions. How do you guys think about that? Maybe Pete, because you're sort of, if you're moving from the happy world of centralized machine learning, how would it feel to manage this at the edge?
Yeah, and I guess one of the things that I both like and maybe a problem with, edge devices is that you do end up, I think of them almost as just standalone objects. They may not even have any connectivity at all, which is why calling them edge devices makes them.
Yeah.
But if you think about, my hope is that we keep them simple enough and we're able to do enough QA on them that they're just like other devices that we put out in the world that are not updatable, like washing machines and windscreen wipers and things like that, that we have tested and that we understand thoroughly enough that we don't actually have to sweat the the whole update and security process.
How do you think about that, Hugo? Because if there's no one got fired for buying IBM, that became no one got fired for buying Google Cloud, right? How does the risk profile of doing more at the edge affect your the clients you work with?
I think, funnily enough, most of those processes are still driven by people doing manual work, right? Verifying what are the versions, what are the conflicts, doing some of the testing manually, etc. So I think actually it's an opportunity on its own to start applying some of these principles, because to be perfectly honest, most of the problems that you have in terms of privacy, it's when someone forgets to do something or change a password or lock up data. Right? So I think there's a huge opportunity to apply those principles in making this a more efficient and more thorough work. Obviously, from a services perspective. I think from a disruption perspective, there's huge potential of how does the software actually update itself according to what it's necessary, depending on the type of device that it is and the type of use case that it's serving.
Yeah, if you look at the processor memory architecture of the Apollo space missions, they're actually significantly less than what we have in a small 16-bit pickle. And they had software update, right? They actually used to fix stuff in flight, which is pretty impressive. In fact, you look at the things that just left the solar system that had software updates in flight for recompressing video. I mean, unbelievable. So you can do it. If they're not connected, you have an issue. But then these devices are so low end that recycling them is not such of a big issue. Of course, if you're embedding the thing, if you've got a fuzzy logic washing machine controller, that you keep your typical domestic device for 15, 20 years, you might want to think about update. But Microsoft wrote a paper, Microsoft Cambridge wrote a paper about Windows Update, the architecture, how they do Windows Update. And it was quite impressive. I can't remember the conference, but more than 10 years ago. It was like, how do we update 600 million machines in the world in an hour? Right? What do you do to push an update? Right? And how do you do that securely so people know they're getting the right update, but if it's a security patch, it doesn't reveal to the bad people before anything's been patched what the patch is? There are solutions. I mean, not saying they're completely finished, but there are some nice solutions for that. But in the place where it's disconnected, it's a low-end device, it costs 50 cents. Well, maybe at some point you go, well, we need to get a new one of those. That's okay. It's not like we're throwing away something. Well, you could probably design it to be recycled if you want to be super.
Yeah, my hope is that we'll actually have some magic magnet thing that you can pick up all the defunct tiny devices that you have scattered around.
Or
otherwise,
think of this as your 3-year-old iPhone that you have to recycle because they just changed all the cables yet again.
Could I be able to make more money if I plugged all of my phones and just left them home and put them in a platform where that capability could be leveraged by a third party? Is that a business model, right?
Yeah. I've seen that in developing countries, actually. So take old phones. A lot of the phone companies will ship. You send back your old phone when they give you a new one, and then they ship them to developing regions to build sensor systems. Yep. And great, that's good.
Do you think that in some ways, and this is a bit of a leading question, we're going to have increased, risk of contagion of sort of security issues with, so much new connectivity and so much more centralization? Do you think in some ways this could be a way to increase the resilience and robustness of these networks?
So, I mean, one of the things I really hope with a lot of these models is, at the moment, computer programs are very, very narrow about what they're looking at. If you can actually have a neural network that's aware of context, so that hey, if it notices that there's a fire happening in the building, it's not just going to kind of ignore it and carry on, like trying to play the next iTunes track for you. You know, that is the sort of thing that might actually make things more resilient if you have lots of individual agents that actually have hopefully some common sense.
And do you think that there's a way in which that description you've got of sort of something that's much more tied to your home, for example, that this increases the level of sort of self-sovereignty around this kind of data, or is that actually a sort of misnomer?
Yeah, I'm not sure. What do you...
Well, that's a goal. I mean, I think there's a kind of range of people that view that whether they want that or not. And there's some people I know, the UK seems to have more than other countries.
Yeah.
It seems to be cultural, but I think it does help with that. It's not the. It's a bit like privacy. It's not the primary selling point. We heard the sustainability, interactivity, the availability. All those pieces were more important. But I think it is a kind of secondary but useful value. Yeah, I think that's, and also having a range of behaviors also adds to resilience. That if people behave differently, then homogeneous attack will fail, and that's a good thing. You want a larger gene pool of systems to sustain against significant bad actors out there.
Yeah. I think we're about up, right? The last question I have for you guys is how early are we really in this? As you guys see, there's obviously lots we've talked about today that's real and happening and in the world of business. You're obviously thinking about this hard. How kind of early on are we in this shift?
Should I start?
Well, if you want to take the Vint Cerf position, the US National Science Foundation defunded the Internet backbone in '92. So I think we're at that point in this world.
Okay. I think that no one's going to top that. All right. Great.